So analytical geometry, this is a comprehensive example, so it will encompass everything we did in our sessions on distance formula, midpoint, and then gradient and straight lines as well. Okay, so the first, well, here's our diagram firstly. They give you coordinates D, E, and F, and there's the y coordinate is missing there, so they just replace it with K. Right, and our first question, they're asking us to calculate the length of DE. Okay, so yeah. So we need to find DE, the length of it, and we're going to use distance formula now. So x2 minus x1 squared plus y2 minus y1 squared. Okay, and you're just going to plot in what you do have. So you have the coordinates for both D and E. Right, square root, I'm going to say negative 3 minus 3 squared plus y2 is 3 minus negative 5 all squared. So DE is equal to, so now we're just going to simplify underneath the square root sign. Negative 3 minus 3 gives me negative 6 squared plus negative 3, a negative times a negative is a positive, sorry, so it's 3 plus 5 squared. Okay, negative 6 squared is 36 plus this is 8 squared, right? So 36 plus 8 squared is 64. 36 plus 64 gives me 100, so the square root of 100. So then DE, or the length of DE, is 10 units. Okay, that's your first question. The second question now asks you to determine the gradient of DE, right? So let me just erase the board. Okay, so think about the gradient formula and what the gradient formula is, right? So our gradient is m, small m, of DE is equal to y2 minus y1 over x2 minus x1. Okay, so y2, 3 minus negative 5 over negative 3 minus 3. Okay, simplify that. Negative times a negative is a positive, so it's 3 plus 5 over minus 3 gives me negative 6. Okay, so we have 8 over negative 6. This can be simplified further, so it's negative 4 over 3, and I'm going to leave it in fraction form. Okay, that was our second question, right? Now, our third question says determine the value of K, yeah, if DEF is 90 degrees. Okay, so they told us this angle here, DEF, is 90 degrees. So what do we know? Well, we do know what the gradient of DE is. It's equal to negative 4 over 3. From our previous videos, we know that when two lines are perpendicular to each other, so i.e. when it's 90 degrees, then the gradients, or the product of the gradients, must equal to negative 1. So therefore, if I want to find the gradient of EF, then I'll say the gradient of DE times my gradient of EF must equal to negative 1. And we can make the statement because DE is perpendicular to EF. Okay. So now we know the gradient for DE, it's negative 4 over 3 times the gradient of EF is equal to negative 1. Therefore, my gradient of EF must equal to 3 over 4. Okay, so now we know the gradient of line EF. So we can use this in order to calculate the coordinates of K. Okay, so my gradient of EF is equal to 3 over 4. Now my gradient formula, again, y2 minus y1 over x2 minus x1. My gradient of EF is 3 over 4. Fill in what you know. So negative 5 minus k over 3 minus negative 1. Okay, 3 over 4, negative 5 minus k. 3, a negative times negative is a positive, so 3 plus 1 is then 4. Now to get rid of, or to isolate the k, we multiply both sides by 4. Okay, our 4's cancel on the right hand side, but they also cancel on the left hand side. So we're left with 3 is equal to negative 5 minus k. Okay, to make things easier, I'm going to take k over, so it becomes positive k and then negative 5 minus 3. So k is equal to negative 8. That's our third question. Okay, k is equal to negative 8. Now, the fourth question says, if k is negative 8, determine the coordinates of the midpoint of line DF. If k is equal to negative 8. So the midpoint of DF, our midpoint formula is x2 plus x1 over 2 and y2 minus y1 over 2. Fill in what you know. x2, so remember it's DF, so it's 3 plus negative 1 over 2, and then, sorry, this should be negative 3. There we go, negative 3, sorry. And then 3 plus k is negative 8 over 2. Negative 3, a positive times a negative is a negative, so negative 3 minus 1 over 2. Positive times a negative is a negative, so 3 minus 8 over 2. Okay, so negative 3 minus 1 is negative 4 over 2. And 3 minus 8 is negative 5 over 2. Okay, so my final answer, the coordinates of my midpoint of DF is negative 2 and negative 5 over 2. I'll leave it like that. And that is our fourth question. Okay, our final question now says, determine the coordinates of point G, right, such that DEFG is a rectangle. So you need to know your properties of quads for this. Now, properties of a rectangle, right? We know that the opposite sides of a rectangle are equal. We know that the opposite sides are parallel. We know that the interior angles are 90 degrees. Okay, so if I draw roughly, yeah, oh, that was very bad. Let's try that again. Okay, that's my very rough drawing of a rectangle. Okay, so I'm going to find the coordinates of G by inspection. Okay, so I'm going to look at the translation from D to E, or you can look at the translation from E to F. Okay, so my translation from D to E, that's what I'm going to go with. Now, to get from our X, right, of D, which is negative 3 to 3, we're going to add 6, so I'm going to say X plus 6, right? Then my Y, to get from my Y coordinate of D to my Y coordinate of E, so I'm going from 3 to negative 5, I need to minus 8. Okay, and that's my translation. Now I'm going to use this translation and apply it to GF. Okay, and we can only do this because we know that the opposite sides are equal. Okay, so then I'm going to take my coordinates of F, and that's negative 1 plus 6. My Y, we know, is negative 8. So negative 8 minus 8. Therefore, G is 5 and negative 16. And that's it. Thank you for watching our video.